galaxies. Unfortunately, unlike what you can see in sci-fi movies, this opportunity is not going to present itself anytime soon. However, we're quite able to observe our galaxy's neighbors even today. There are currently dozens of galaxies nearest to us known to science, large and dwarf ones, with the data about them continuously flowing in. Of course, it is too early to talk about a friendly visit there, but if a chance does present itself, where can we set out first? And what is there beyond the boundaries of the Milky Way? Cosmo. The first in outer space. Galaxy is a common name for a system of stars, clusters, interstellar gas, dust, dark matter and planets which all are bound together by one gravitational energy. All objects in a galaxy are in motion with respect to the general center of its mass. As a rule, these are really remote astronomical objects, with the distances to them measured in megaparsecs. We can make out only several of them with the naked eye. The Andromeda Galaxy, seen in the northern hemisphere, the large and small Magellanic Clouds, seen in the southern hemisphere, and the M33 Galaxy in the Triangulum constellation, seen from the northern hemisphere as well. The exact number of galaxies in the observable part of the universe isn't known, but their number may well reach 2 trillion. Only in the 20th century was it made possible to observe some of them. By the early 1990s, not more than 30 galaxies were registered where stars were visible and which were part of the local group, that is, the cluster of galaxies forming one large whole known as the Virgo supercluster. After the launch of the Hubble telescope in April 1990, however, the inflow of information about new galaxies soared dramatically. Today, they are subdivided into several general classes. The first class is satellite or companion galaxies, which are objects orbiting around a larger galaxy due to the gravity of the latter. The second class is spiral galaxies, which are peculiar for the central bulge cocooned in a disk. And the third class is irregular galaxies, typically unsuited to either of the proposed categories. As a rule, they are chaotic formations with neither a clear nucleus nor spiral arms. Lenticular or SO galaxies, elliptical galaxies and barred spiral galaxies like our own Milky Way fall into this category too. The approximate diameter of each of them ranges from 5 to 250 kiloparsecs or 16 to 800,000 light-years. Just to compare, the diameter of the Milky Way is 30 kiloparsecs, that is 100,000 light-years. The largest galaxy known today is called IC 1101 and boasts the diameter of over 600 kiloparsecs. The principal problem in studying the structure of a galaxy is the mystery of the dark matter. Today, the dark matter is believed to account for up to 90% of the overall mass of a given galaxy. Alternatively, another galaxy may be completely devoid of it. But which of these objects can be defined as the nearest to us? Many would argue that it's the Andromeda Galaxy that is the closest, which is located 2.52 million light-years away. However, this is the closest object among the largest spiral galaxies. As for the closest galaxy, a hypothetical Canis Major Dwarf Galaxy should be named. This astronomical object belongs to the local group as well. The galaxy contains a comparatively high percentage of red giant stars and presumably a billion regular stars. It is classified as an irregular galaxy and is officially considered our nearest neighbor. The galaxy is located 25,000 light-years away from the Solar System and 42,000 light-years from the center of the Milky Way. This object was discovered in November 2003 by an international team of astronomers. In spite of its close location to the Earth, the galaxy wasn't easy to spot, because it is located beyond the plane of the Milky Way in the area with stellar, gas and dust overdensity. Our second closest neighbor is the Sagittarius Dwarf Elliptical Galaxy, which used to be considered the first one as well. It is a satellite galaxy with a clearly defined elliptical structure with its orbit passing over the Milky Way. The object contains 4 globular stellar clusters, with the first of them discovered in 1994, which led to the discovery of the galaxy itself. Its diameter makes up about 10,000 light-years. It is about 70,000 light-years away from the Earth and 50,000 light-years away from the core of the Milky Way. It is thanks to this galaxy that the Milky Way may have obtained its arm structure. This conclusion is based on numerical modeling. It was arrived at by researchers from the University of Pittsburgh. According to their version, the arms of our galaxy may have been obtained as a result of a collision with the Sagittarius Dwarf Elliptical Galaxy. This object is currently in the process of merging with the Milky Way. It should be noted that it has passed through the plane of our galaxy several times. The last time took place about 150 million years ago, which agrees with the data received by the Gaia telescope. When speaking about our nearest neighbors, one can't but mention the Large and the Small Magellanic Clouds, 2 dwarf galaxies and satellites of the Milky Way. The Large Magellanic Cloud is 163,000 light-years away from us. That is a distance twice as big as the diameter of our galaxy. The Large Magellanic Cloud finds itself in the area between the Dorado and Mensa constellations in the southern hemisphere, which is the reason why it is unlikely to be seen from most of Eurasia. The galaxy is approximately 10 times smaller than the Milky Way and contains approximately 30 billion stars. The mass of the Large Magellanic Cloud is about 300 times as small as that of our galaxy. However, it does not prevent it from holding the 4th place among all the local group galaxies in terms of its mass, beaten only by the Andromeda Galaxy, the Milky Way Galaxy and the Triangulum Galaxy. One of the best-known objects in this galaxy is WOH G64, a star considered to be one of the largest known to science. Its radius is 1,540 times that of the Sun. Hypothetically placed in the core of the solar system, it would reach as far as the orbit of Saturn with its edges. The Milky Way and the Large Magellanic Cloud are expected to collide in approximately 2.4 billion years' time. Its neighbor, a Small Magellanic Cloud, should also be mentioned. It is a dwarf galaxy too, and is enveloped in neutral hydrogen. The small cloud is 60 kiloparsecs away from us. That is approximately 195,000 light-years. It is located in the Tucana constellation and has the appearance of a faint spot about 3 degrees in size. 1.5 billion stars are thought to be found in the Small Magellanic Cloud. However, they are not visible from most of Eurasia either. According to the data published in September 2014, the Milky Way is likely to swallow up this object as well in 4 billion years' time. To date, the number of satellite galaxies in the Milky Way equals 18, but the number of large systems closest to us reaches 115. This is hardly the full list of these objects, because new dwarf systems are discovered now from time to time not far from the Milky Way. Pinpointing and exploring objects like that is a rather arduous task. However, the search for nearest galaxies remains one of the chief objectives in astronomy today. Their discovery might give us insights into new planets similar to the Earth and might lead to the discovery of life forms in the nearest parts of the universe. I hope you enjoyed the video and were excited to find out more about our nearest galactic neighbors. Thanks to advanced technologies, we're able to receive a lot of data on the formation of nearest cosmic structures today. Based on these, we can arrive at conclusions about our Milky Way as well. It's in our power to share this information, so that these achievements become known to the widest audience possible. If you are inspired by these discoveries as much as I am,